My mission is to discover the language of nature, and I believe nature is intelligent.
Pure, wholesome milk.
I like milk for all the good, healthy things that are in it.
Mankind's most nearly perfect food.
Good, fresh, healthy milk.
A fungus is now producing the same protein that makes cheese melt, stretch, and taste like real dairy. Not a plant, not a synthetic substitute, a fungus. And if that sounds like a niche scientific breakthrough, it isn't. Because hidden inside every carton of milk is a secret that could threaten one of the largest agricultural industries on Earth.
I'd like to meet you, but I'll bet you're hoping for a hug.
I'm drinking milk, though. Milk's about the best thing I can drink right now to help me build strong arms, powerful legs, and a broad chest. And when all my work is done, will you love me just for my body?
Milk is almost 88% water. The proteins that create cheese, yogurt, butter, and most of dairy's economic value make up only about 3.3% of its volume. For more than 10,000 years, humans have used cows to manufacture that 3.3%. Now, scientists are teaching fungi to do it instead. Inside industrial bioreactors, genetically engineered fungal cells are consuming plant material and producing real dairy proteins directly into liquid broth. No cow, no pasture, no milking. Just biology running on command. Supporters say this technology could use a fraction of the land, a fraction of the resources, and dramatically reduce the environmental footprint of dairy. But hidden beneath that promise is a much stranger story. Because while scientists are building fungi that can replace cows, corporations are racing to patent the building blocks of food itself. Powerful dairy organizations are lobbying governments to restrict what these products can even be called. And regulators are struggling to keep up with the technology that is already moving into the marketplace. What started as a biotechnology experiment is becoming a battle over who controls the future of food. And at the center of it all is a fungus. The biggest secret in the dairy industry isn't hidden inside a laboratory. It's hidden inside a nutrition label. Every morning, tanker trucks carrying thousands of gallons of milk leave farms around the world. Most people assume those trucks are transporting nutrition. In reality, they're mostly transporting water. Nearly 88% of milk is water. The fats, minerals, vitamins, and proteins occupy only a small fraction of what's left. But hidden inside that fraction are the molecules that matter: caseins, whey proteins, the compounds responsible for cheese, yogurt, butter, texture, structure, and flavor. Without them, milk loses most of its value. For thousands of years, humanity built an enormous industry around extracting those proteins. We bred cattle, built barns, cleared land, created refrigeration systems, constructed global supply chains, all to harvest a few percentages of protein from a liquid that is mostly water. And for most of human history, there was only one way to get them: a cow. Then somebody asked a dangerous question. What if the cow was never the product? What if the protein was? That question changes everything. Because once you stop viewing dairy as an animal product and start viewing it as a protein manufacturing system, an entirely different future becomes possible. A future where the cow becomes optional. Inside research laboratories across Europe, scientists weren't trying to create a better cow. They were trying to eliminate the cow entirely. The technology is called precision fermentation. The concept sounds almost impossible. Researchers identify the exact genetic instructions responsible for producing a valuable biological molecule. Then, they transfer those instructions into another organism capable of manufacturing it. In this case, fungi. One target quickly became especially important: alpha S1 casein, one of the key proteins responsible for the texture, melt, and structure of real cheese. Without it, many dairy products simply don't behave like dairy. For centuries, there was only one reliable source of that protein: a cow. Now, scientists have another. Researchers insert the genetic blueprint responsible for producing casein into microbial hosts capable of growing rapidly inside industrial bioreactors. Then, something remarkable happens. The fungus begins producing the same protein normally produced inside a cow. Not a similar protein, not a plant-based version, the same biological molecule, functionally identical. This is why investors became interested. This wasn't another milk alternative trying to imitate dairy. It was producing the exact proteins that make dairy what it is. For environmental groups, it looked promising. For venture capital, it looked profitable. For the dairy industry, it looked dangerous. Because if fungi can perform the most valuable function a cow performs, one uncomfortable question suddenly appears. How much of the cow is actually necessary? But even this breakthrough had a problem, a very expensive one. The biggest obstacle wasn't biology, it was lunch. Most precision fermentation systems rely on expensive feedstocks, refined sugars, purified glucose, highly processed inputs. The technology worked, the economics didn't, at least not yet. Then, researchers connected to a project known as funcows proposed something even stranger. What if the fungus could eat grass? The same thing cows eat. Organizations including Those Vegan Cowboys, Bioscience, and researchers associated with Leiden University began developing a fungal platform capable of growing on grass-based feedstocks. The idea sounds absurd until you realize what they're actually trying to do. A dairy cow converts grass into milk proteins. The funcows project wants to remove the middleman. Cow. Grass becomes milk. Fungus. Grass becomes casein. No livestock, no milking parlors, no breeding cycles, no herd management, just protein production. If successful, the implications become enormous. Supporters claim systems like these could require dramatically less land and significantly fewer resources than conventional dairy production. Industry projections estimate the precision fermentation dairy market could grow from roughly $4.5 billion in 2026 to nearly $18 billion by 2030, a growth rate most industries never experience. Investors see opportunity. Scientists see possibility. Entrepreneurs see a new food economy. But traditional dairy producers see something else, an existential threat. Because if the economics work, the disruption doesn't stop at milk. It spreads through the entire dairy industry. Imagine you own a dairy farm. Not a hobby farm, a real operation. Hundreds of cows. Millions invested in land, equipment, feed, labor, and infrastructure. For generations, your business depended on one assumption. If people want dairy, they need cows. Then suddenly, they don't. Analysts at RethinkX argue that precision fermentation could trigger something known as a disruption spiral. The reason goes back to that same number, 3.3%, the proteins, the valuable part of milk. Once those proteins can be manufactured directly, traditional dairy enters a completely different competitive landscape. Because precision fermentation behaves more like software than livestock, bioreactors become more efficient, processes improve, costs decline, scale increases, technology compounds. A cow doesn't. A cow still needs feed, still needs land, still needs water, still gets sick, still ages. One system follows the economics of technology. The other follows the economics of biology. And historically, technology tends to move faster. As alternatives become cheaper, demand begins to shift. As demand shifts, traditional producers lose revenue. As revenue falls, costs become harder to absorb. Prices increase, more customers leave, and the cycle repeats. The frightening part isn't that dairy disappears tomorrow. It's that disruption often looks impossible right before it becomes obvious. For more than a century, industrial dairy looked permanent. For the first time, that assumption is being challenged, and that's when the political war began. The fungus hadn't escaped the laboratory yet. It wasn't producing commercial cheese. It wasn't sitting on grocery store shelves. Most people had never even heard of the Fungus project, yet the fight had already begun. Because the moment scientists demonstrated that fungi could manufacture the same proteins responsible for real dairy, a new threat appeared. Not biological, political. Across Europe, the United Kingdom, and the United States, dairy industry organizations began pushing regulators to restrict how alternative dairy products could describe themselves. The battle wasn't over whether the products worked. The battle was over what they could be called. Milk, cheese, yogurt. Words that seem ordinary suddenly became valuable territory. According to reporting by Greenpeace Unearthed, dairy lobbying groups pushed regulators to crack down on terms such as yogurt style and cheddar type. The products weren't being banned, the names were. At first, that sounds ridiculous. Why would anyone care about a word? Because words shape markets. Consumers understand cheese, they understand yogurt, they understand milk. Force competitors into unfamiliar categories and adoption becomes harder. Confuse the customer and you slow the competition. Supporters argue these restrictions protect consumers. Critics argue they protect market share. Either way, the target wasn't just the product, it was the fungal replacement itself. Because for the first time, dairy wasn't competing against another dairy company, it was competing against a fungus. But while one side fought over names, another fight was unfolding behind closed doors. Ownership. For thousands of years, nobody owned casein. Nobody owned the proteins inside milk. Farmers owned cows. Companies owned brands. Cheesemakers owned recipes. But the molecules themselves belonged to nature. Now, food tech startups are racing to patent production methods, fermentation systems, and biological processes connected to precision fermented dairy. The irony is difficult to ignore. One side wants to stop the disruption, the other wants to own it. And somewhere in the middle sits a fungus, quietly making milk proteins in a steel tank. A fungus that may ultimately change who controls food itself. And perhaps the strangest part of the story is that nobody outside the project knows exactly what fungus they're using. The Fungus Consortium has never publicly revealed the species. For a project trying to reinvent one of humanity's oldest foods, the organism at the center of it all remains largely anonymous. That secrecy isn't unusual in biotechnology, but it creates an interesting mystery. Because scientists could have used many different organisms. They could have used bacteria, they could have used yeast. Instead, they chose a fungus. And there are good reasons for that. Long before fungi were making dairy proteins, they were already serving humanity in ways most people never notice. Fungi help produce antibiotics, industrial enzymes, organic acids, food ingredients, pharmaceutical compounds. Entire industries quietly depend on fungal biology. In many ways, fungi are already some of the most successful manufacturing systems on Earth. They've spent hundreds of millions of years evolving ways to break down complex materials, process nutrients, and survive in environments where other organisms fail. Scientists aren't creating those abilities, they're borrowing them. The Fungus project simply takes that idea one step further. Instead of asking a fungus to make enzymes, instead of asking a fungus to make pharmaceuticals, researchers are asking it to do something completely unnatural. Become a cow. And if that sounds absurd, consider what the fungus is actually doing. It doesn't understand milk. It doesn't understand cheese. It doesn't understand agriculture. Researchers inserted new instructions. The fungus follows them. That's it. No intent, no awareness, just biology executing code. And that may be the deeper story hiding underneath all of this. The future of food may not depend on inventing entirely new organisms. It may depend on teaching familiar organisms entirely new jobs. Long before this fungus learned how to make milk, it was already doing something remarkable. Humans had simply never asked it to become a cow. And now that they have, the technology is beginning to leave the laboratory. Which means the next phase of the experiment won't happen inside a bioreactor. It will happen in the real world. Turn to that bioreactor. Inside, billions of fungal cells are carrying out instructions written by humans. They don't know what milk is. They don't know what cheese is. They don't know they're participating in one of the most important food experiments in modern history. They're simply following biological code. For thousands of years, humanity believed dairy required cattle. That assumption may be ending, because the true product was never the animal. It was the protein, the molecular architecture hidden inside the milk. And once scientists learned how to separate that architecture from the cow, the future of dairy stopped being an agricultural question. It became a technological one. Somewhere inside a stainless steel tank, a fungus is quietly performing a task cattle have carried out for millennia. Not because it understands farming, not because it understands food, but because biology doesn't care where an instruction comes from, only whether it works. And for the first time in human history, a cow may no longer be necessary to make dairy. The cow was never the product. The protein was.